Welcome everyone. This is 1.1 on domain, range, and behavior. So we went into module 3 and now we're on module 1. And module 1 is all about how to describe a graph. Okay, what the different characteristics of a graph is or are. And then the first lesson of this module, we're talking about the domain, range, and behavior. Okay? So the domain you guys should know the definition of and the range as well. So I just wrote it down. Domain is all possible x values, whereas the range is all possible y values. Okay. So here, if we look at this graph and we're trying to find the domain and range, remember that the domain is all possible x values. So it's right here, right? So then it's all the horizontal values that you have. Okay? It's all the horizontal values that we have. And our y value, y-axis is here. And it's all the vertical values that we have. Okay, so if it's all possible x values, okay, for our domain, and looking at this graph, here, the lowest point is negative 11. The highest point is at 7. So all of my x values will be between negative 11 and 7. Right? Simple, easy. And then we're going to learn how to write that in terms of math notations in a little bit. Okay? The range, the highest vertical value that you have is 6, right? And that point right there. The lowest y value that we have is at 1, which is right here, right? And notice that the lowest value doesn't necessarily occur at the point. Okay, it doesn't necessarily occur here. Okay, at 2. Okay, there's a lower one at 1, right? So be careful of that. So the range is between 1 and 6. Okay. Questions? No? Okay. So now how do we write this in terms of math notations? Okay, there are 3 math notations that we have to do, or we have to talk about. The first one is interval notation. Interval notation, it looks like a coordinate. Okay, just like if I had a coordinate x on the xy chart, right? 6 comma 1, you guys would know what that coordinate is, right? How to graph it. So it looks like a coordinate. So you have 2 numbers, right? I'm going to put blank, comma, blank, just like a coordinate. Okay. And that left-hand side number will represent my lowest value. Okay. My right-hand side number will be the highest value. All right. Okay. So just based off of that, if my domain is between negative 11 and 7, my lowest value is negative 11, comma, my highest value is 7, right? Lowest, comma, highest. Simple, easy, okay? And then just like a coordinate where you have parentheses, right? Here are some rules. If that lowest value, or in my domain, if that negative, or if negative 11 is included in with my domain, right? It's gonna be brackets. I'm gonna use brackets, okay? If it's excluded, then I am gonna use parentheses, okay? That's the rule, all right? So looking at my domain, going back up to my graph, looking at my domain, okay? Here at negative 11, I have that, and here at 7, I have that. So is it included or is it excluded? Those values at negative 7 or negative 11 and 7. Included, right? Negative 11 is a part of my domain, correct? Because this point is closed circle, right? If it were to be an open circle here, then I would say that it's excluded. Does that make sense? But since this is closed circle and also at 7 it's closed circle, I'm gonna put brackets around it. Okay. And I also found out that if it's included, it will be a closed circle. And then if it's excluded, it would be an open circle. Okay. So that's how you would represent that interval in terms of interval notation. And now interval notation, you guys are going to use this from now till forever. Okay, this is just your first exposure of interval notation. Okay, all right. The next one, you guys already know, it's inequality. So if my range is between 1 and 6, how do I represent that in terms of an inequality? If it's two finite points like this, 1 and 6, I'm gonna go, my lowest value is 1, my highest value is 6. I know it's my range, so it's my y values, right? My y values are between 1 and 6. So looking at it from left to right, 1 is less than y, which is y is less than 6, right? That means that it's in between those two values, correct? So here, 1 and 6, am I correct? Looking at 1 and 6 on my y values, is 1 and 6 included or is it excluded? Included, right? Because 1, the value of 1 is right here. The value of 6 is right there. Yeah? And they're both included with my range, correct? So if it's included, it must be that it's less than or equal to. Okay, not just less than. Because it can equal 1 and 6. So if I go back up to that list, right, of included and excluded, I can add another thing, right? It's included when it's bracketed, when it's closed circle, and when it's less than or equal to, or greater than or equal to. It's excluded when it's just less than or greater than. Okay? Cool? All right, so that's my inequality. I want to copy this, and you guys will see why right now. My third way is set notation. Okay, set notation Do not overthink it. Okay, it's just a way of writing it in terms of math. Okay, set notation, all we're gonna add to our inequality is fancy bracket, fancy bracket. Okay, use those fancy brackets, and then we're gonna say the range, so it's y. This line right here is a vertical line, just one straight vertical line. This line means such that. So y has a value such that, that one is copy and paste, where y is between and can equal 1 and 6. Yeah. Because you're going to plop your inequality right in there. Okay? Simple? Easy? Questions? No? Yeah. Right? That's my third way. So I have all three ways, right? The inequality, set notation, and interval notation. So now let's practice. Okay? Here I have a finite interval. Finite interval just means I know the two endpoints. I know this value is going to be between -3 and 2, right? So how do I write that in terms of an inequality? If x is my, change it up, x is my variable. Yeah, perfect. Okay. He said it's equal to because they're closed circles. So set notation wise, again, do not overthink this, right? It's just a way of writing it out. Fancy bracket, x such that, copy and paste. Plop it in. Okay, cool. All right. And in interval notation, remember interval notation is lowest comma highest, right? Values. So what's the lowest value? -3, comma. What's my highest value? 2. So is -3 included or excluded? Included, because it can equal -3. So I'm going to bracket. At 2, included or excluded? Included, so it's bracket. Okay, so it's bracket, -3, comma 2, bracket. Okay. Let's take a look at this one. -3 to 2. Can we come up with the inequality? Less than or equal to 2. Yep, that's it. Set notation. Again, please do not overthink. X such that, I'm going to write it out now. -3 less than x less than or equal to 2. Bing, bang, boom, you are done. Okay? Interval notation. Lowest number is -3. Okay, -3, comma. Highest value is 2. Around the -3, open or close? Or, I'm sorry, around the -3, parentheses or brackets? Parentheses, because it's an open circle, right? So that means that -3 is not going to be a part of this, right? Okay. At 2, open or parentheses or brackets? Bracket. Okay. Cool. Yeah. Simple, right? Okay. Let's talk about an infinite interval though. Notice the reason why it's infinite interval is because it goes on forever. So it starts off at 2, this number line starts off at 2, and it goes on forever towards the left-hand side, right? So what's the inequality? Yeah. Sorry?
X is less than or equal to 2.
X is less than or equal to 2. Awesome. Again, do not overthink the set notation. Once you get the inequality, it's pretty simple. X such that X is less than or equal to 2. Plop in the inequality right in there. Okay? Interval notation. Well, you have what's the highest number? Let's start there. Highest value is 2. What's the lowest value? Alex? Infinity, but we are on the negative side of it. Yeah, remember infinity would look like this. This is the infinity symbol. This is the infinity symbol. And it's always going to be negative because I'm on the negative side of it. So it's negative infinity. So it's going to go all the way to the left and never stop, right? So it's an idea. It's not a real number, right? It's just an idea that it's never going to stop. So around 2, is it brackets or parentheses? Bracket, because it's included. And since negative infinity, if you're talking about negative infinity, can you put a number around negative infinity? Negative 1,000. That's a pretty big number. Is that where we're going to stop at negative 1,000? No. Negative 2,000? Negative 2 million? Negative 3 million? Negative 5 million? Negative 5 trillion, though. That's a pretty big number. Can I stop there? No. How about negative 100 trillion? Negative 333 trillion and 50. No, I don't care. You don't care what the other numbers?
Nope.
No? So since there is no number that we can include, right? It's always going to be parentheses. Okay? It's always going to be parentheses around a negative infinity and a positive infinity. Okay? Because there's no number that we can put in, right? Okay? So what about this one? X is greater than 2, right? That's my inequality. Again, with the set notation, X such that X is greater than 2. My lowest value here is 2, comma, what's my highest value? Infinity. Okay, again, infinity, we cannot grasp it, can't put a number on it, so we're going to just put parentheses. How about at 2? Parentheses as well, because at 2, it's not included, right? It's excluded. Cool? So, always parentheses around negative infinity and positive infinity because there is no number that I can include in our set. Therefore, it is excluded. Okay? Cool? Questions? So you know the three ways, right? Inequality, set notation, and interval notation. All right? So moving on. Ooh. What about this guy? Consider the interval shown on the number line. It's going forever, right? In both directions. Yeah? So what is the lowest number if we have to use interval notation here? Negative infinity. What's the highest number? Infinity. Questions on that? It's never going to stop on both directions, right? So it's positive infinity or negative infinity, comma, positive infinity. And since those infinities, we're never going to include it, right? Because we can't put a number on it. They're going to be excluded. Okay. What does this interval represent? What numbers? Does it represent 1? Does it represent -1? Does it represent 10,000? Does it represent -10,000? Yeah. So if it represents all the numbers, it's all real numbers. Okay. What the symbol for all real numbers is a paragraph symbol, P, right? But instead of a P, it's an R. Okay. So it looks like a cursive R. Okay. All right. The last thing we're going to talk about is end behavior. And end behavior end behavior answers this question of what is going on at the ends of the graph. Okay. So how do we locate the ends of the graph? Well, let's take this for example. Okay. Hold on for a little bit. So what is going on at the ends of the graph? So how do we locate the ends of the graph? So if we look at this graph on the board, right? And the x-axis is your lifeline, okay? Your personal lifeline, okay? All the way to the left of the graph, right? Everybody was born, correct? And let's say the y value is just your actions, just for fun, okay? So everybody's actions at age 0, what is that? What is your action though? Everybody has the same action. Unless you came out saying, hello, mother. I am here. Huh? You're crying. Yeah. You're crying, right? Everybody cries. Everybody. I don't care who you are. Right? Everybody cries, and that's the signal to everybody in the room that you're alive and we can go from here. Right? As long as you're breathing, everything else will take care of itself. Right? That's the best feeling in the world when the baby cries. Not now at age 4 and 8, but now or back then at age 0, that's the signal of okay, we got through that one of that big hurdles, right? And you're alive. Okay. That's the left-hand side of my graph, right? That's where my graph starts, correct? Yeah. And all the way to the left or right-hand side, right? You go through your ups and downs. Right now, you're a teenager, right? So you guys have your ups and downs, left and rights, and whatever you're going through this life, right? And let's say that you die at the ripe age of 120. And if you guys want to live more than that, good luck. Okay? At 120, everybody has the same action, right? Yeah? Everybody dies. Yeah? I know two things about your life that everybody has. You guys were born, and you guys will eventually die, right? That's kind of gruesome, but it is what it is. But what this idea is, right? And what is going on, the end behavior is what's going on when I am here or when I am here. When I am here at age 0 or when I am here at age 120. What's going on to my graph or where is my graph going? That's end behavior. So if we turn that into this graph and we answer that, right, to this graph here, how we describe the ends of the graph, it's not going to say as I was born, right, as this example does. It's always going to be as x approaches what value? If I want to represent 0, where is my x value approaching? Or what value is my x value approaching? My x, yeah. What value is it approaching? As I keep going on and on and on and on and on, where am I going towards? Huh? I'm going towards negative infinity. Yeah. So as x approaches negative infinity, how do I describe the end of the graph positively? I'm going this way, right? Living my life. And I'm going all the way, all the way here. Where am I approaching? Positive infinity. So as x approaches negative infinity, or as x approaches positive infinity. Where is my graph, my y value, going towards? Okay, so this part here, class, represents your end behavior. Okay, it describes your end behavior. And then all you're going to do is answer that part of it. Okay, so here, looking at this graph, and I'm going to just erase all those little markings. Okay, here on this graph, as x approaches, as I keep going towards negative infinity, my graph here goes up and up and up and up and keeps on going up, correct? And it never stops because of this arrow, right? It keeps on going up. If it keeps on going up and up and up and up and up and up and up, where am I headed towards? Positive infinity, right? Awesome. Yeah. So y approaches positive infinity. And as I keep on going this way towards positive infinity, where is my graph headed towards? It's going up and up and up and up and up and up and up, correct? So my y value is headed towards positive infinity as well. Does that make sense? Yeah. So this would also be positive infinity. Okay. Questions? No? I'm going to end the lesson here today. Okay, that's end behavior. And 1.1 on domain, range, and end behavior.